Hello, my name is Minyoung Nam, and this is a short demonstration of our tool called ASIIST. We're going to demonstrate scalability analysis first. So ASIIST loads in an ADL model. So after running the tool, you can load in the ADL model, the file which you have selected. And once you load in the model, you'll see all the partitions and the applications assigned to that partition. Then we can run the analysis by pushing the button, and then you can find out whether the task or the partition is schedulable or not. Also, it includes information about from which application it receives what size of data, so that the user can know where it receives data from. In cases when a partition is unschedulable, you can also modify the size of the partition and redo the analysis to make it schedulable. Next, we're going to show the graphical view of our tool. So if you don't want to see just the table, you can always see a visual graphical view of all the partitions and the applications assigned to them. And what you can do is you can detach a application from a partition and move it to a different partition. Once after you move a application, then you'll rerun the schedulability analysis, and then in this case it'll be unschedulable. Of course, to make it schedulable, you would increase the size of the partition and then rerun the analysis. Next, we're going to demonstrate the bus delay analysis of our tool. So compared with the scalability analysis, this time it loads up the model and shows all the logical connections inside the model. And for each logical connection, it also shows the hardware flow that exists because of that logical connection. Now, after running the analysis, it's going to update the table with all the delays for each connection. So this is the worst case delay. Also, we have a graphical view for bus delay analysis. After pushing the button, you'll have a new window which shows the hardware platform of the model and all the connections that exist on the hardware. But we try to filter all the connections because there's so many, so we have several methods to filter only the problematic connections. So in this case, it only shows the connections that's close to their 90% of their deadline. So if I decrease the connection to 0, it's going to show all the connections. Also, you can limit the set of connections from the table on the right, and when you select a partition or a hardware component, you can also limit the connections to be shown only the connection that exists on that partition or the connections that go through that hardware. So after selecting the problematic connections, you can also change the coloring scheme to differentiate between the connections. We also provide an editor where you can change the hardware flow settings. We represent the hardware flows by a list of hardware components. So this editor basically helps you input that hardware list. Next, we're going to demonstrate another feature of drag and drop of applications. So previously, for the scalability analysis, we were able to move an application to a different partition. When this happens, you have to know, you would expect that all the connection specifications should be updated as well. So we also do that automatically. So once if you move a application to a different partition or even a processor on the network, then it's going to move the hardware flows accordingly. So after moving the application, you can see that all the stall application related connections has been moved to the processor on the second. And then since all the connections has been moved, you have to redo the analysis. Thank you very much for watching, and hope you get to use it.